This is Nama.
This is Alyssa.
And this is Diego.
Coming to you from
Super
Science! Have you ever been to the United States before?
Yeah, I used to live there.
Me too.
Well, you've definitely gone to Pennyback, right?
You mean like this?
Exactly.
So what about it?
Well, what are pennies made out of?
Copper, right?
That's where you're only half right. Nowadays, only 22.5% of pennies are copper, and the other 97.5% is made out of zinc.
Really? How is that even possible?
Oh, I think I've read about that. I think it has to do with electroplating.
Exactly. Electroplating is a single replacement reaction. By using the same basic theory of electroplating, we should be able to plate copper onto aluminum.
Okay, so what materials will we need to use?
We'll need a copper wire, an aluminum sheet, 2 alligator wires, aluminum nitrate solution, 1 beaker, and a timer.
Wait, but how are we going to carry out a single replacement reaction if copper is low on the utility status in aluminum?
Why do you have that, Diego?
Because I'm awesome.
Okay. Well, what do you think, Alyssa?
Well, couldn't we use a power box? By using alligator wires, we can connect the copper wire to the positive side of the power box and aluminum to the negative side of the power box. Electricity will serve as a catalyst for the reaction.
Good. The copper will be oxidized into copper cations, which will be attracted to the negative aluminum sheet, thus coating copper onto aluminum.
Sounds like a plan. Let's do it.
Okay. Okay, well, this is our second step. We're pouring the aluminum nitrate into a beaker, and we're going to pour 250 milliliters.
Okay, I'm gonna mask the copper wire and the aluminum.
So now we're going to place the copper wire into the aluminum nitrate solution. And we're going to connect the wire using, we're going to connect the copper wire using this wire to the battery onto the positive side, which is over there.
So next, I'm gonna clip the alligator clip onto the aluminum sheet and the other side to the negative side because it's the one being electroplated.
Okay, so what we did in order to make sure that the aluminum and the copper don't touch is that we taped the wires to the beaker so that they won't move. And now we're going to turn on the electricity and time it, and after 5 minutes we'll stop and weigh each metal again. So what do you think's happening, Alyssa?
I think that copper nitrate is being formed at the bottom. As you can see, there's blue right there. And
Technically, the aluminum should add weight and the copper should lose weight.
yeah, because see, look, little black, a black precipitate.
Okay, we're taking out the metals now.
Face it so it's like facing the camera.
The copper and the aluminum have both switched colors, and now we're going to mask them.
Yeah, so as you can see, the bottom of the copper wire is lighter in color. It's probably because it's losing some of the element.
There is some particles of copper floating around the solution.
Hopefully, hopefully when we turn the power box back on, it'll float to the aluminum sheet.
And bond.
Okay, so we're gonna do this again. Okay.
Okay, we're going to start the battery again.
And wait, time. How do you do this? Okay.
Okay, well, what we see happening here is bubbles are forming on the aluminum just because it's redox for like water. But we're not sure why it's not forming on the copper right now, but yeah. Also, if you look really closely at the bottom of the aluminum, it's turning a goldish color, which means that the copper is coating the aluminum, which is good. And I think that if we leave it for longer, we'll see a big change because all the copper that's in the nitrate should be gone, and the aluminum should turn different colors. As you can see, this is the aluminum. And before it was this color, it was a very silverish color. And now here at the bottom, it's turning gold.
Coppery color. So now we're going to go mass and see if there was an increase. Okay, so we're gonna turn the power box on for a third time and observe the masses again afterwards. So start the clock. So as you can see, the solution is becoming more blue because it's forming copper nitrate.
Okay, so it's been 3 minutes, and this is our third set, so now we're going to turn it off and mass both the things again. And this will be our last time massing it.
Okay, so after 20 or so minutes of electroplating, this is the product. So as you can see, the copper has plated the aluminum.
It's a different color as well.
And the copper wire continued to degrade until there's nothing left. So obviously it's shorter from the original length of the copper wire, and it's really pointy at the end, like a needle.
Also, the solution in which we carried out the reaction became a green color. It originally was clear, so this we think is because of the copper ions that are now in the solution.
So the purpose of this experiment was to explore how electroplating worked. So we coated copper onto aluminum to kind of mock what happens when in the penny making process.
Our experiment was successful. We were able to get the copper to coat the aluminum using the electricity, and what happened was that the copper lost mass, and the aluminum sheet gained mass because it was transferring cations.
Something that we learned was even though copper was below aluminum in the activity series, using electricity we could still coat aluminum with copper.
So this is Nama,
This is Alyssa.
It's Diego.
coming to you from
Super Science! Woo!